Good to see you both.
Good to see you.
Great. Well, you've been partnering over the last few decades, and I'd like to start this conversation by taking us to the current state of the union as it relates to early stage investing, and particularly in deep tech, and really dig into why now is the right time to start Walden Catalyst. So Lip-Bu, you've been an investor for over 3 decades. What's unique about today?
This is a very exciting time to invest in deep tech, and couple of key points. One is there's a 5 generation waves happening at the same time, and then you have the 5 generation waves include AI, machine learning, industrial 4.0, and autonomous driving, and the cloud, and the AI machine learning. So I think it's a really exciting time. And meanwhile, there's about the data-centric era. It's all about data. And you heard about the cloud, and right now we call about the cloud continuum. And also the purpose-built to address some of the different workload of the requirement. And then, so I think AI machine learning is changing the game. And basically using AI machine learning, you have multiple verticals is really taking off. Like the medical, biotech, drug discovery is one of them, fintech, and crypto platform. And all this is a lot of innovation, a lot of unicorns to be made. And this is an exciting time. Young and I, we share the same vision to invest in the deep tech. And not many deep tech players that have the operating background that both of us have, and the network we have to make it to scale.
Indeed. And Young, you've been a CEO of many companies. You've been a venture capitalist and an entrepreneur. So I think you have a really unique view on this topic. The current environment is different from it used to be. And what do you see as uniquely advantageous?
I think we're in a very interesting time where things are changing in such a rapid way. It's creating a new opportunity for many entrepreneurs that are in front of us. One of them, obviously, what Lip-Bu mentioned, the cloud is enabling all of our opportunities to run things from any distance. Obviously, I call this 4 Cs. First is, of course, the coronavirus, the C that we didn't expect. But what it did was, I think, made an enabler most of our business that can be done through the cloud. And then, obviously, the other one is the consumer. Being able to provide tools that can be able to make your job effectively no matter where we are, and being able to do more precision medicine type of opportunities using new technologies are also very exciting. And consumer experience will be such an important part of what we develop going forward. All those cloud and consumer experience wouldn't be possible without chips. And you may think that even vaccine wouldn't be able to develop without chips. Why is that? Without having a great gene sequencing technology, being able to isolate through mRNA, being able to replicate that clones, and then being able to see how it interacts with our human body is all part of a journey where technology is enabling the new reality that we are living in.
Well, it's good that you brought up chips, because as 2 captains of the semiconductor industry, you're intimately familiar with the environment. I got to ask you the hot question of the day. What's going on with the semiconductor shortage, and how is that shaping the business environment?
I can start first.
Yes,
first
please.
Of all, I think clearly the demand is so strong, like I mentioned earlier, is a data-centric era, and also the 5 generation waves. So the demand is really strong. And then the problem right now we have is a lot of components in manufacturing in Asia, and some of this because of pandemic, they shut down the factory, and then some of this component is not the most advanced nodes component. It's kind of more the lating nodes. They call it feature-rich nodes, and basically they are all in big shortage. And then the other part is this logistic is a big problem. From the container, shipping, the union worker, the truck driver, and that compound the problem. And as you know, building a fab, it takes about 3-4 years. And so it's not like over time you can kind of turn the key, the factory will be running. And some of the equipment, it takes about 6 to 9 months to install. And so long story short, I think we're going to go through some challenges. I think right now a lot of customers, big automotive CEO call me up, said, Lip-Bu, I want to know more about the supply chain. How can we build longer-term relationship? So this is a great time for us to be an investor, to help some of our portfolio, to connect with some of this leading customer, and that's truly value that we can provide together.
Yeah, indeed. And Young, your view on this?
Yeah, just a great example of the typical automobile requires 1,300 semiconductor components. And as you know, if you just miss one part, you cannot build a car. So the reality is that we are so used to just-in-time delivery. And then when pandemic hit, we all had different decisions to make. Where we invest, when we shut down, how we travel, and all those changes create a signal mismatch. So we're not having this precise signal that we used to have, and to be able to deliver supply chain. I think for entrepreneurs, there's a huge opportunity to figure out how to manage supply chain much secure, much in time, with a much greater visibility. So I see that as an opportunity, but it is a current challenge. And it does take a lot of money, planning for semiconductor industry, or any really deep tech related areas. It requires a vision, it takes planning, and I think it's going to take time. But it is an opportunity for us to change. It's a great opportunity for people like us that are looking at how we can fix the problems.
Yeah, well said. And thank you for painting the overall picture of the world today, as I think it really gives us context for what we're talking about next. So zero in and talking specifically about Walden Catalyst, how is the firm positioned to capitalize on this massive data economy? Young, do you want to start?
Sure. I think that opportunity for data is there, and I'm going to show one slide here. If you look at, and Lip and I have been talking about this, the data is doubling almost every 2 years. And it's structured data, it's unstructured data. But when you put it all together, we have to figure out what that means. And our ability to analyze data is about 2% of those data is being analyzed. There's so much information that we can help us to learn and improve our applications. We believe there is an explosion of data that are creating incredible opportunities. And I think the reason we believe there's also a possibility we can be able to take this advantage of data is because compute, the modern compute, is much, much more powerful than it used to be. And I think it's to do with what traditional Moore's law that are creating the processors. And then on the top of that, we have accelerators. And on top of that, we now have the data bricks that can be able to help you with AI. And then, of course, the advancement in AI that can give you the what I called accelerated learnings, as well as the supervised and unsupervised ability to transform and making meaning out of a lot of this tons of data. So I think that's a really exciting part of the era that we're in. And we call it this golden age of modern compute with 1 million times potential. And Lip-Bu and I have been talking a lot about this area. And I think maybe Lip-Bu, you can talk about why you think it's a great time for this 1 million times of potential in this time frame.
Yeah, I think this is an exciting time. I think, as you mentioned earlier, it's a very data-centric era. Compute, the performance, the scaling is tremendous. And so there's a lot of new technique in terms of like chiplets, how to scale it, and how to drive the power down, because the Moore's law is slowing down, and some new materials need to be required. And so I think this is a very opportunity time for innovation and investment in the deep tech, and then how to scale. And then the other part I think you talk about is software 2.0. In the past, you build the hardware, and then you try to figure out the software to make it work. Yeah. And now it's the other way around. That software define the purpose. Then you build the silicon, build the system to supply that. And this is a sea change happening right now.
Right. This is just incredible time. I think Lip and I have been in industry for over 30 years. And I think great opportunity doesn't come every year, but it does come every certain waves. And we believe it is the era of the data wave, and the new compute, new architecture is required to take advantage of this wave. And we call it this 1 million exponential opportunities. One are driven by what Lip-Bu discussed earlier about new materials, new architecture that are really the fundamental to enabling it. And then, of course, the software stacks and the AI and software 2.0 that can be able to generate new machine code that can be able to accelerate that. Let's go down a couple of slides here. So first part, we also believe there is a whole new opportunity for new hardware architecture. And as you know, I started my career in Silicon Valley working for Intel. So I'm a classic microprocessor person, and that has dominated the last 30 years. And then over the years, I moved out of Intel, joined ARM, and ARM became the new architecture. So every mobile phone, every device you use are based on ARM. Now, question is, what's next? And I think this is the topic that Lip-Bu and I have been discussing. Lip-Bu, what's next?
Yeah, I think this is an exciting time. The instruction set is kind of given, but now how do you build purpose-built architecture based on the different workload, and then how do you optimize it, and also drive the power down and efficiency for that. So I think that's a new era coming up. And then open source, you want to embrace the open source. So I think the RISC-V starting to take off, adoption is accelerating. So I think this is an exciting time.
Right. So you're going to hear later on one of the company that are based on RISC-V architecture to do really what I call the next generation architecture we believe that are coming. And it is one of the things we get really excited about. The other thing I think we're really excited about is the way the data is managed today and where it's going. So if you look at in the past, old data stack was really around typically your applications, whether it's the customers, whether it's your product, or your employees. And there is a particular dedicated application servers that are serving each of those apps. So it could be Workday, it could be SAP, or even Cadence tools that are enabling to run your applications. And that has some advantages because it gives you the performance you need for typical applications. Well, when the data is going to cloud, like you see from here, data warehouse is now being able to meet all your data in one place, whether it's customer data, product data, employee data, and then you're transforming the way the modern data stack is going to evolve. And that's where we are today. And we are very excited that we can be able to address using the open compute architecture to exchange this data so that the data you have can be able to run it regardless of which hardware, regardless of which framework you're using to run it. And I think that is the future of where new data stack is going. And it is an exciting part. It's the exciting part of the journey. And another company will be talking about this afternoon regarding the journey in this particular area. So you'll be stay tuned for that discussion. The evolution of semiconductor has been really interesting. And I want to ask Lip-Bu to talk about how Cadence or other EDA companies enable what is possible today in silicon.
Yeah, before I address that, maybe go to the previous slide. And then basically, I think I call it the cloud continuum. And it's not just a cloud, and there's about 16 billion devices going to be created and for the edge. And then, in fact, the future of the cloud is the edge. Right. So how do you provide the data continually into the cloud and then to the on-premise? And that's huge. That means that you want to decide the data in the distributed way. And so you need to have a unified platform that able to address the data from the edge to the cloud and based on what the optimization that you want to drive. Right. And so rather than each silo that you described earlier. So I think the next company that we really going to highlight later on is the Voltron that provide that unified platform on the data that able to move the data as it go, and then so they will not be stuck in the different silo. And of course, you have to address the security, you have to address the data movement in the very optimized way. So this is exciting. Very exciting.
We're really excited about the possibility of moving the data you have is not stuck in one location, but the data you have has a continuum of opportunities.
And I think in some way, second question that you asked about Cadence.
Yes.
So I think that part of Cadence is as we move into from EDA to we call it the intelligent system design. So in the way using our computational software expertise, how to drive all the way to the silicon, to the system level, to the service provider, and how to optimize that. And there's a new field to open up from all the IP blocks that you want to assembly, and then really drive using AI machine learning to drive a little bit like self-driving car.
Right.
You drive the design automatically, and that is tremendous value in terms of time saving and efficiency. And that's one example, how do you use the data to your own advantage to scale it distributedly.
Yeah. You know, I don't know that you know that today, without this complex semiconductors, the world cannot run. And I remember the early days of the semiconductor days where you have to actually lay out these chips one by one, testing one by one. Today, now we can create 100 billion transistors based densities based on semiconductors that are all done by tools, simulations, validation, verification, and then when the chips comes out, it works in one scoop. So that would not be possible without the evolution of the tools and the technology that come out of the EDA industry. Like that, I think there is a huge opportunity that we learned from semiconductor in IT industry can apply to other industry as well. The intersection of biology that Franz Ho talked about with IT is really happening in front of us, mainly because now we believe we can be able to model the high complex proteins, or like RNA and DNA sequencing we have done. All that information can give us so much more insight around how we can simulate, like Cadence has done. Now we can model it, we can simulate it, we can test it, and then we can be able to automate it. And that whole process will accelerate drug discovery, better diagnostics, which in turn it should be able to make a much better impact on our health. And we believe this combination of the multidisciplinary opportunities between biology and technology is a very exciting area. You want to add any comments?
No, I think you highlight very well. I think this whole medical using the data to more accurately addressing the patient-specific medicines and using the accurate biomarker to help us to really optimize and know the data well enough, and then have all the clinical data to look at all the side effects, and when the drug discovery can be more effective and more productive. Yeah. So this is exciting field.
Yeah, and together, actually, thanks to you, Lip-Bu, you introduced me to Berkeley Life.
Yes.
That Dr. Ming's project out of Berkeley, which in turn enabling to automate cellular isolation and automate to produce the good cells, so that exactly what you're describing, we can be able to improve personal medicine as an example of that, right? There's so much more opportunities that are coming. So I think that one of the things we really get excited about going forward is really around this idea of the hundreds, 10,000s, or millions of opportunities that have really changed the way we can analyze data. Traditionally, we were bound by Moore's law. Now, I think going forward, we are really not bound by anything other than our ability to transform these unsupervised trainers with a very small amount of data that can give you much insights. And I'm really excited that we are involved in this journey. We invest in a company called AI21, where you're going to hear from Dr. Yoav regarding his view of what it means going forward. And really it's about giving human intelligence into the data that you have. And the question is how we do that. And this set of parameters that are going into understanding your natural language processing is bigger than you can imagine. 175 billion parameters that can enable you to be able to learn about the way we write, the way we read, and then when you can be able to use, I'm already using actually their applications called word tools that are helping me to write better than actually I normally would be, depend on what context. And that's just incredible to me because I speak English second language. And our ability also read the New York Times articles and give you a synopsis of what's going on. Imagine having one of those things when you're going MIT.
Yes.
That would have been very useful to shortcut some of our homeworks.
We can finish our graduate degree faster.
Yeah, exactly, and some other stuff.
I think it's very clear that you both have a very specific and unique thesis in this area. So in the way you paint about the future that we can all have and are currently progressing when we can harness the power of 1 million X computing power is very exciting. So any other last words?
I think I have one slide that I think maybe I can paraphrase. You know, people have been saying the software is eating the world, right? Just came out of this neighborhood. I'm not going to say who. But we believe now AI is eating software. And this is software 2.0. And we believe in it. And this is our core thesis of investment.
Agree.
Thank you, Lip-Bu. Thank you, Young, for this wonderful conversation. And certainly, we have very exciting prospects to look forward to.